This conference will now be recorded.
Okay, so today we will discuss about storage concept and different type of storage which is available for VMware infra. We will discuss about all of them. So let's begin with this particular slide. Okay, so these are your ESXi host which has number of VM running into it. We have multiple type of data stores. One is VMFS, second is NFS in green color. Then your data store is coming out of some backend storage device. So there are different storage technology. One is directly attached. You can say direct attached. Or second is fiber channel. Third is FCOE. Fourth is iSCSI. Fifth is NAS. So these are different type of storage technology. Behind the scene, the storage is available. Physical storage devices are available, which is converted as a data store and presented to the ESXi host. Okay. All four technologies, direct attach, fiber channel, FCS, and iSCSI, will discuss in detail. All four can be converted into a type of data store which is known as VMFS. VMS is a file type of data store. Just like you have in Windows NTFS FAT32 partition type. So similarly, we have VMFS here in ESXi. You format any data store, it will be formatted as a VMFS file system. Another option, if you're behind storage, is NAS, network attached storage. It will be treated as a file system and it will be converted as an NFS data store. Okay, all of them we will discuss in detail. So there are certain points which you should remember based on which we can classify your storage types. First is, what is the storage device you are using. Second is which protocol you are using. Okay, third is which type of connecting cables you are using, cable or switches. Okay, so basically there are three criteria based on which we are dividing our storage technology. Okay, so storage devices can be of many type. Similarly, your storage infrastructure can use number of protocols. Okay, and similarly you can use a device which is fiber channel. The axis of fiber channel is based on light, you know it, data transfer in fiber channel based on the light source is in the form of light. So one example is fiber channel, another is iSCSI, and there are certain other example like FCOE, fiber channel over the Ethernet. You are transferring your storage data over the Ethernet cable, LAN cable you can say. Okay, so those are different type of devices, different type of cable, different type of switches which you use to connect your storage to the VMware infra. Okay, so one by one we'll discuss. So keep in mind these 3 points based on which we are dividing the entire storage concept. Okay, so let's see what is DAS. So that is this is actually direct attached storage. Internal or external storage disks are attached to the host. So if you have one physical server on which you have installed an ESXi host, next to it you have some local storage devices. So what you have done is you have directly connected to it. Okay, so in the DAS, you are directly connecting your storage to the server. Okay, so it is number of disk directly connecting to the host. So they call it DAS devices. Okay, second is fiber channel, a high speed transport protocol used for SAN networking. So fiber channel, they call it a protocol, type of protocol by which you can connect your SAN. So this is the most common type of storage we would be mostly using in our infra. So you have some fiber channel switches, you have some cables, fiber channel cable, dedicated fiber channel cable. Okay, then this is your ESXi host suppose. This is your ESXi host. This is your cable fiber channel. This is your fiber channel switch. Just like in our network or LAN, we have LAN switches. Similarly, we have FC switches. I will show you some diagram pictures as well. Now this fiber switch is again connected to some cable. Okay, and this cable is going to a huge device. We call it storage array or storage unit. Okay, so this is actually having a storage controller, storage devices, number of disk, 1 TB disk, suppose 10, 20 disk, and then cable is coming out. It is going to the switch, and then from switch another cable is going to the host. Okay, and this side we would be having our HBA or storage adapter on the ESXi server. So this is the fiber channel infrastructure or SAN infrastructure. So that is how your storage infra is connected. Second is FCOE, fiber channel over the Ethernet. So let me show you some diagram as well. FC switch. I will click on images. Okay. So basically, you can see this is a type of switch. The company is QLogic. QLogic is a company which manufactures uh, fiber channel switches, and these are the fiber channel cables, FC cable. These orange color. These are the port, you can say, where it is connecting. Okay, so these are very costly devices. Okay, so that is how a switch looks like. Fiber channel switch looks like. Okay. Now our third category in storage technology is FCOE. So what is happening actually, you have one LAN connection, another one is your fiber channel connection. Okay, so in the market, to optimize the cost for less critical infrastructure, we can have those kind of switches which supports both storage as well as network traffic. So in general, you would be having dedicated network switches and dedicated FC switches. But to optimize the cost, you can have a one common switch which will support both the thing. Okay, let me see whether I have any picture on that topic. No. No.
Abu bhai, you are not audible.
Yeah, okay, sorry. I was muted. Okay, thanks. So this is basically your storage device, and this is your LAN connection, which could have internet as well. So your storage device is also connected to the same switch as well as your LAN connection. This blue color is LAN and this black color is your storage connection. So the same switch is being used for both the purpose, storage as well as LAN. Okay. So LAN and SAN, storage, they call it storage area network SAN. So this kind of FCOE. Let me give you one real picture of FCOE switch. Okay, I need to check the detail, so you can check it yourself. Yeah, so this is one of the example FCOE switch. Okay. So basically, what is happening actually, your LAN as well as your storage is combined into one device. So we have a dedicated switch which can work for storage as well as network traffic or Ethernet traffic. From the definition itself, it is very clear. Fiber channel traffic is encapsulated into FCOE frame and converged with Ethernet networking traffic. So it is not one of the common type of storage which is being used. Most common is fiber channel. The reason is fiber channel provide very good performance in terms of storage, because this FCOE does not provide very good performance, because it is using transferring the traffic for both network as well as storage. So it is used for low critical VM, less critical VM. Okay, so DAS, fiber channel, and FCOE. Let's discuss about SCSI protocol. So a protocol wherein you are using the IP address to access your storage device, that is called iSCSI. We will discuss in detail about iSCSI. So let's talk about NAS. Storage shared over the network at the file system level. Up till now, whatever storage was we are discussing was at block level. Entire storage was shared as a block, as a LUN. But in case of NAS, where the protocol is NFS, the NAS is something where individual file level can also be mapped or accessed by the server. So that is called NAS. I understand just discussing about these 4 or 5 type will not clarify everything, but in detail I will try to explain one by one in coming slides. Okay, let me first go to DAS. Let's talk about iSCSI. What and all are the components involved when you talk about iSCSI? So this is your entire storage device which have multiple storage disk attached to it. 1, 2, 3, 4, 5, 6, 7 disks. It could be more based on the capacity. Just for example, you have 7 disks. A disk could be 1 TB or 2 TB, whatever it supports. So suppose each disk have 1 TB. So combined storage capacity is 7 TB. Okay. Out of 7 TB, as per your requirement, you have provisioned or allowed some storage. We call it LUN, LUN, logical unit number. Suppose any server want a 1 TB or 2 TB or 4 TB storage, so we will make it as LUN and present it to the storage server. So this is the entire storage unit. These are the disk, these are the LUNs, and these are the storage processor. What is storage processor? This is basically a small computer. It has its RAM, CPU, processor, everything. So what is the work of storage processor? It actually manages the health. It actually manages the size, capacity, everything. It is responsible. It has operating system as well, a small computer which has to manage the entire storage device, storage disk. If anything goes down, it will replicate the disk, it will give the health status, everything. So we have redundant storage processor, two storage processor always. Reason is if one of the processor goes down, our storage should still be accessible via the another storage processor. So that is the reason we have multiple storage processor. So first is entire storage system, then physical disk, then LUN, then storage processor. Okay. Next is, as I said, in SCSI we use the TCP/IP network, which is based on the IP address. On another side, this was the storage side. On another side, we have our server, ESXi host, ESXi server, or any Windows server, or anything like that. So suppose you have in VMware, you have one ESXi host. So this IP should be, this particular storage should be accessible via our HBA. or a storage adapter, okay, over the HBA. Second is you can have physical HBA as well as software defined iSCSI adapter. In our lab also we are using the software defined adapter. Okay, let me show you. So I have clicked on ESXi host, then configure and then storage adapter. Okay, so we can add one. Okay, so there is some problem. So you can see this option, add software adapter. So you can have one software adapter as well, but to get a very high or good performance you should add a physical adapter, storage adapter. Okay, you can add a software adapter. So notice one thing. So you have basically two thing only. In general perspective, there are only two things. One is your entire storage unit, and on another side you have entire ESXi host, any other server, Windows server, Linux server, whatever is the host. So those host or adapter, they call it iSCSI initiator, which is actually the consumer of the storage, which is actually using the storage. And the iSCSI target is on another side, which is providing the storage. So the one which is providing the storage, we call it iSCSI target, and the one which is using the storage, we call it iSCSI initiator. Very simple. Don't be confused. iSCSI target, the one which is providing the storage. iSCSI initiator, the one which is utilizing or using the storage. Fine. So as I told, iSCSI uses IP address, so we should know that IP address of our target as well as initiator. Okay, and there is some ID is also attached to it to uniquely identify those devices. So target also have his ID like IQN number. Initiator also has its own IQN number. Now I will quickly come to another storage type. Yes, fiber channel, which is very important. So notice the same thing. The storage device which have storage physical disk, hard disk, LUN numbers, different LUN unit, and two redundant storage processor. Okay, this is your entire storage unit. Storage system, physical hard disk, LUN number, and redundant two storage processor. Leave about this middle one. Now come to this host or ESXi host. Again HBA server with HBA. Okay. The only difference you can notice it in previous slide and this slide is In between, earlier what was there? IP networking, IP address base. But here you have cables and switches, which is fiber channel switches and fiber channel cables connecting from storage processor to switch and then from switch to HBA. Try to understand how the connection is going on. One HBA is connected to one switch and which is at the end connected to one storage processor. For the same host, we have another HBA which is not connecting to the same switch but to any other switch. And that switch is not connected to same storage processor but to another. That is the redundancy plan. If your one HBA goes down, this particular path is not accessible. So still you have this path accessible. Or maybe your cable is having some problem or fault. Still your second HBA is connected. This path is working fine. And sometime if your fiber channel switch is down, this secondary fiber channel switch is also there, so you can connect using this FC switch. Or maybe your storage processor is down, then this entire path is down, but still your secondary storage processing unit is still available, so you can access it. So this is the ideal scenario in an critical or highly demanding infrastructure, wherein you have everything redundant: two HBA, two fiber channel switches, two different cable, two different storage processing units, so that if anything goes down in the entire path, either HBA, either cable, or either fiber channel switch, or either storage processing, anything goes down, it could be accessible from secondary path. Somebody could ask me, okay, no problem, storage processor, fiber channel, HBA, everything we have written. What about disk? So let me tell you, within disk also we have RAID configuration, redundant array of independent disk, RAID configuration. What does it mean? A copy of one disk is parallelly copied to another disk as well. If one of the disk goes down, you can still have your data in another disk. Similarly, one disk is copied to another. There are different mechanism, different way you can have your configuration, but in general scenario we have mirror of each and every disk. So even if one disk goes down, your data will be still available because there is a replication between disk 1 and disk 2. So that is how redundancy works in terms of storage. And this is we are talking about fiber channel. So what is the major difference? Again, come to the criteria based on which you are saying that there is a difference. One is storage device. Second is protocol. So earlier we were using iSCSI IP based protocol, TCP IP protocol. Now in fiber channel we are using fiber channel protocol. And earlier we were using simple cables. But in case of FC, we are using FC cable, fiber channel switches. So that is the major difference. Okay. Each HBA has its own unique WWN number. Just like your network adapter or NIC card have a unique MAC address, similarly your HBA has their own unique WWN number, worldwide number. For an L1 or N2 interview, most of the people will ask you what is WWN. You should clearly tell it is a unique number which is assigned to each and every HBA and which is unique in nature. No two HBA can have same WWN number. Okay. So you can identify based on the WWN number. Whenever you will go to your storage team to provide any new LUN of 1 TB, 2 TB, whatever size, they will first question, they will ask you what is the WWN number of your server. So within one server, if you have 4 HBA, you need to tell all 4 HBA's WWN number. So first thing they will ask is WWN number. Then only they can provide you access to the storage device. So let me tell you one more important interview question, zoning and masking. This question was asked to me as well long time ago. What is zoning and what is masking? So zoning is a technique which is done at particular switch level by storage team to grant the access to your host. Like this host want to connect to this switch, then somebody should provide the access to this particular WL1. Otherwise, even if you connect the cable, you will not access it. You will not be able to access it. So somebody should allow this particular WL number to connect to this particular switch. Okay, once you are connected to the switch, you can access any of the LAN. So this is at only switch level, but again, this particular host can access any of the LAN, but you don't want your another host to access particular LAN. Suppose LAN number 12, you don't want this particular host number 2 to connect or access my LAN number 12. This particular storage I want to be not available to my another host. So for this, you need to do LAN masking. What is masking? To hide. So you can do it like, you can say like, okay, for switch you have access, but this particular LAN is not visible to you. This particular LAN, you can hide it. So those kind of command line thing can be done by the storage team. We as an VMware admin never do such kind of thing, zoning and masking, but you should be aware about the concept, what is going on. Okay, so this is the difference between zoning and masking. I will share you one good article, zoning versus LAN masking. Okay, this picture is enough to understand the concept. And this masking also is, this picture is enough to understand the entire theory or concept. Oh, there is something wrong. No problem. Let me do one thing for you. Let me make it easy. So zoning and masking is a technique which is done by our storage team to provide the access. Okay. So top 4 devices in black color, those are actually your server. Okay, let me show you parallel masking. Then only you will be able to understand the difference between zoning and masking. Why I am stressing more about this topic is it is very important and it can be asked multiple times in your interviews. What is the difference between zoning and masking? Bear with me just one more. Okay. Okay. So there are two connection. One is with red color, another is with green color. Okay. In this picture as well, one is red, one is green. Okay. So what is happening in zoning? You have four server 1 and server 2. What you did is you have allowed in green color, you have allowed those two server to have access to your 1 and 3, these two storage devices. Okay, your server 1 and server 2 can access to your storage device 1 and the storage device number 3. Your server 3 and 4, which is in red color, could not connect to storage device number 2 and 3 and 4. So this is a story about zoning. So individual server, you can restrict them from accessing to the storage devices. So this policy or this technique is called zoning. This is done at switch level. What is happening in masking? You have only two server. One server is able to access the device, storage device. Another server is also able to access the storage device, same device. At switch level, same storage device can be accessible to both the server. Okay, but within one storage device, I told you we have different LUN number, LUN number 1, LUN number 2, LUN number 3, LUN number 4. Suppose each LUN is of 1 TB, 1, 2, 3, 4 TB. So total storage device of 4 TB, you have created 4 LUN, 1 TB. So one server can access to LUN number 1 and 2 only, this green color. But second server can access the storage but cannot access 1, 2, 3, 4, all of them. Or maybe you can restrict to any three, only any three kind of thing. So at the LUN level, you are masking it. It is called LUN masking. But at the switch level, you're providing access at the storage level. That is called zoning. That is the main difference. I will give you this website link. You can read out yourself and try to understand. It is very clear concept. No need to worry about it. Okay, so that is, they call it zoning and masking. So till now we have discussed about direct storage, iSCSI and fiber channel, three type of devices. Now we are coming to FCOE, four type of device. Okay. So basically again same thing, you have one LAN connection for IP addressing, another is your SAN connection for storage array, but you can connect same both the cable to same switch, FCOE switch. It is actually another type of hardware. We support both the thing. So one cable for LAN, one cable for SAN, both you are connected, and then it could be again two cable could be connected back to your ESXi host, which will support both network as well as storage devices. But to segregate the traffic at the host level, you should have network driver as well as storage divider or FC driver. Converged means you have combined both the thing. So we have adapter which is of FCOE type, which supports both the frames. Okay, so hardware is underlying hardware is also changed. Adapter is also changed, which is converged, cable, then switches which support both the technology. So this kind of storage called as FCOE. So one thing is left out is NFS. One important thing is left out is NFS. Okay, component of NFS. Again, your storage device is replaced with NFS server. You have same host with a NIC card, network adapter. You have IP networking. Okay, ESXi host with network adapter, which is added to the switch, virtual switch. Your NFS server, which has NAS device in the backend, network attached storage device, server with storage. Okay, so the storage is not shared as a LUN, but it is shared as a file. So there is actually a difference between block storage and file storage, file level. So this particular directory is already created. You have some files like notepad file, any folders kind of thing, all those kind of thing you already created. So you just map it using the IP here and it will be accessible. Those files can be accessible. You need not to format them. Okay. So you have one IP of NFS server. Give me a second. Okay, I'm back. बोलो नहीं ना class चल रही थी. Okay, while you're accessing the file server, you need to have the IP address of the NFS server. Then the folder or the path, because one NFS server can have multiple paths. So whatever path you wanted to share, you just share it. Okay, then you just mention the NFS data store name. That's it. Any questions so far?